Hello, everybody. I'm going to talk very fast because this is a lightning talk. I don't have enough time. Anyway, I'm going to talk about dissecting a Go channel. Why we want to dissect a Go channel? Well, there's a channel have a data. It's a data structure in your runtime. So I'm going to show how it behaves under the hood by following an approach, an experimental approach, basically analyzing that in live. For that, we are going to need an scalpel, a microscope, and the subject. This is going to be my scalpel. I'm going to use unsafe to take that the pointer to the channel and put that information in a struct that I made that is an equivalent struct to the one that is in the Go runtime. And I'm going to return that struct. And then my microscope is going to take that struct and print that into the screen. And this is my subject, a channel. In this case, I'm using a in32 four elements buffered channel. This is the structure. You have a lot of data there. You have a log that is global, two lists of send queue and receive queue that are queues for Go routines. We are going to see more about that later. We have the queue count, that is the number of elements that is in the channel. The data queue size, that is the size of each element in the queue. The data queue size is the size of the buffer. The element queue size is the size of each element. And the element type is a pointer to the element type that you are going to store. And the buffer is just a list of positions. In this case, it's going to be 4 positions for in32 elements. But if you have a different type or a different size of buffer, that buffer is going to change, of course. So let's see what happened. I can create my channel and use the scalpel to open it. I looked with the microscope, and what I'm going to see is that the queue count is going to be 0 because there's nothing in the queue. The queue size is going to be 4, and the element size is going to be 4 because it's in32. The buffer at the beginning is completely empty, full of zeros, and there's two pointers there. That is the send x and receive x that are not really pointers, are integers that point to the place where the next send or the next receive is going to check. And the send queue and the receive queue, that is the two lists of Go routines. If I insert element in the channel, what is going to happen is now the queue count is 1 because I have one element in the queue, and the element is added to the buffer, and the send x is increased. If I add more stuff there, now I added 4, 3, 2, 1. When I added 4, I'm going to see here that is 4, 3, 2, but there's no space for the 1. So now my queue count is 4, and there's not enough space for anything else. So the last Go routine that was the last insertion that was doing here is going to take the Go routine and say, I'm not going to be able to send that, so I have to wait. So put itself in the send queue and park itself and put the Go routine as waiting, and it's going to wait until somebody wakes it up. Okay, if we keep going and somebody read from that, what is going to happen is it's going to read the first element there, the 5 that we saw there. The pointers are going to be updated, and this is going to wake up the Go routine that was in the list, and that Go routine that was in the list, after being wake up, is going to insert that in the buffer here. And everything keeps going. Then, if you get another element, you get this element here, that was the 4. You can see here the response, and the queue count is now 3. If you keep reading from the channel and you just keep reading and you get the 3, the 2, the 1, and suddenly there's nothing to read because the queue count is 0. So the Go routine is going to add itself to the list and park itself and wait. And whenever you close that, it's going to send this close here, and it's going to change this close from 0 to 1 here, and that's it. If you want some references, basically this is by reading the source code of the Go runtime. So if you want to check that, is this file in the Go runtime is relatively easy to read. Also, if you want to try it by yourself, there is a code in my GitHub repo. And if you like it, there is a talk that I did that is a complete talk that is called Dissecting Slices, Map, and Channels in Go that follows the same approach for slices, map, and channels, and with more air in between all the words that I'm saying here. So thank you.
Never mind. It can stay like that. Doesn't have to be full screen. Hello. I'm John Lenton. I'm a staff engineer at Quiet.ai in the infrastructure team. I've been a Go developer for 10 years now, and it's been a lot of fun. This week, I noticed something that bugged me, and Horacio Duràn encouraged me to address it and see about working it into a proposal for improving Go. This lightning talk is a story of what that was and how that went. Let's write a bit of code to see what we're talking about. Let's imagine we have a fairly large test suite with some unit tests, but also some integration tests with a fairly involved setup and fixtures and the like. Setting up those fixtures would log some information that might be useful if the test failed. Obviously a simplified example. This, of course, works well. So we add another test, which also works as expected. Yes? But there's duplication, so we move the common code out into a little helper in its own little file, and we call it from the tests. Okay? Now, sometimes that's what you get when you do that. Sometimes this is the log message you want. Sometimes you want the error to point at the helper. But sometimes you want it to point at the test that's failing, because that's where the problem is. And the helper isn't really adding any information. It's making it harder to debug. Especially if the helper is setting up a mock or something like that's not really special. The log package has log logger, which has, log logger object has an output method that lets you specify the call depth so you can do something like this, exactly what we wanted to do. But testing TB does not. So what does what does t.error do, or t.log? The testing T embeds a testing common, and error and its friends are actually on the common bit. And they all call a private log, and the private log calls log depth with a nice little constant 3 there. And what we wanted to do is change that, which is deep inside their guts. So we discussed this with Horacio on Sunday. And Sunday evening, Horacio wrote a patch instead of sleeping, because, yeah. And this patch was quite good, and it was good enough that we were thinking of bringing it as a proposal. And we've been using Go for 10 years, and I don't see anybody lifting their hands or getting excited about this. Did you know that testing TB had a .helper method? Because we didn't, and we've been using Go for a while. And it's been there since 2017. And you use it like that, and it does exactly what we wanted to do. The end.